Eyes on the board. Mouse closed. I'll wait until everybody's eyes are on the board. I'm still waiting, and we are already recording. I think, yes, we're already recording. I'm going to bring this back over here. Okay, when we're finding volume, the true definition of volume is trying to figure out how many cubes we can fit inside an object. Okay? For surface area, we found out how much area we have to create this box. Now for volume, we're trying to fill up the box. Okay? So after we figure out how much cardboard we can fit in here, after we figure that piece out, now we can figure out, since we're making a box, don't we usually fill up a box with something? Is that correct? So that's what we're trying to find today when we find volume. How much can we fill it up? And we're going to use cubic units. In this case, it's going to be cubic centimeters. So we're going to try and figure out, and again, please excuse my drawing, but we're going to call this 1 cubic centimeter. And here's why it's 1 cubic centimeter. It's 1 centimeter here by 1 centimeter here and 1 centimeter high. Length, width, and height. We would call that 1 cubic centimeter, or you can say 1 cubic centimeter. Does that make sense to everybody? So we're going to try and place, how many of these can we fit in here? Make sense to everybody? So when I know that this shape right here, one way that almost everybody in here knows volume is they know it as length times width times height. But on your formula sheet for your 6th grade MCA, you're going to say volume is equal to big B times H. And the big B is equal to area of base. So that's the formula we're going to use. We're going to get away from using length times width times height and find area of the base times the height, because that's what our formula. Does length times width times height still work? Because you know what? For a rectangular prism, our big B is equal to length times width. For a rectangular prism, that's true. Yes, sir. Sure. That's the answer. But I'm going to try and diagram why it is your answer. Yeah. It is 60. Can I show you why? If we know that it's 3 centimeters high, so what I can do is say, here's 1 centimeter, here's 2, and there's 3. Everybody agree with that? And I have to do that all the way around. 1 centimeter, 2, and 3. Can everybody see that fine? Kayla, can you do me a favor and turn off the lights so we can actually see this? Okay, now, you're going to see the cubes in just a second. If this is 4 centimeters wide, that means I can fit 1, 2, 3, and 4 centimeters. Everybody see the 1, 2, 3, 4 centimeters there? And then on this one, it's 5 centimeters long. So 1, 2, 3, 4, and 5. And I did not draw those proportional, did I? They should be equal. Okay? So when I look at this, we can figure out the area of the base. And the area of the base is going to be basically that first level. Or if you want to think of it, it's like the first floor in a building. Let's look at this building, and we can see there's 1, 2, 3 stories high. Does everybody see that? Okay. And this first floor is going to have a grand total of 20 cubic centimeters in it. It's 1 cubic centimeter high, and it's 4 by 5. Does everybody see that? So I can see 1, 2, 3, 4, 5. Oh. All right. So we would go through and we'd say 4 by 5, and this equals the base by itself, the area of the base is going to be our 20 centimeters squared. Now we need to multiply it by how high it is, the height. So yes, 4 times 5 times 3 works, but you're going to get questions that will say, if the area of the base is 20 square centimeters, what is the volume? And you'd have to find the height. Or they'll give you the volume of 60 and say the area of the base is 20 centimeters. How high is the building? Okay. Yes, ma'am. Question. Say again. So when we take 20 centimeters squared and multiply it by 3 centimeters, 3 groups of 20 is what? 60. Now what is centimeters times centimeters squared? Centimeters cubed. It is. It's centimeters cubed. Because remember, repeated multiplication means that we're talking about exponents. So we have centimeters cubed. Everybody okay with that? Yeah. Okay. So we're going to try another one. We're going to try and find the volume of this. And my first question for you is going to be, what is the area of the base? In other words, what is the big B in our volume equals area of the base times height? What is the area of the base? What is the area of the base? It's 6 long by 4 wide. That's going to be the area of our base. So what is 6 times 4? 24. So our area of our base is going to be 24 centimeters squared. How high is it? 2. So if we take our 24 and multiply it by our height, what's 24 times 2? 48. So we will have 48 cubic centimeters, or 48 centimeters cubed. Everybody okay with that? I think the rectangular prisms are pretty easy. Okay. Let's try one more. I'm not going to help you at all. I'm going to ask you in a few moments what's the area of the base. Then I'm going to ask you what the total volume is. Okay. What's the area of the base? Our big B, our area of the base is equal to 15 centimeters squared. And he got that by doing 3 by 5. Okay? That means on the very first floor, there's 15 centimeters. In fact, how many groups of 15 centimeters do we have in all? How many groups of 15 centimeters do we have in this entire building? three groups, right?
Yeah.
We'd have the first one right here, where that whole piece is 15. We'd have the second one here, where that whole piece is 15. And then we'd have the third one. So we have three groups of 15. So what is the total volume of this? 45 centimeters cubed. How do we do? Now, do you think label is important for this? Label is very important because if we put 45 centimeters squared, you'd only be finding one small level. That would be 4 centimeters. Oh, sorry. Let's do it easier. 5 centimeters this way by 9 centimeters this way. And that is 45 centimeters squared. That works for a two-dimensional shape. Okay? That means we can have 45 squares inside here. So there's a big difference between centimeters squared and centimeters cubed. And then if we just said 45 centimeters, that would just be a line that would measure 45 centimeters. See the difference between the labels? Here we're trying to find cubes. We okay with that? Who can tell me the volume? Who can tell me the volume? Shh. Who can tell me the volume? Shh. It's 70 what? Shh. Shh. Okay, what's the area of the base? What's the area of the base? 35. The area of the base? What's that? What's the area of the base? R big B. It's equal to what? It's 35. Can you tell me why it's 35? What's that? Yep. That would be this level right here. 7 times 5. Okay? And we have two of those, two groups of those, for a grand total of 70 centimeters cubed. Okay. Now I'm going to caution you on, we still are going to follow the formula. Volume is equal to area of the base times height. Shh. Our area of our base for this one, if we're going to use that formula, even though this triangle is not standing up like this, our area of the base is going to be equal to the triangle on this one, the area of the triangle. And we have to do that every time if we're going to use this formula. We're going to say the area of the base is the triangle, and then our height would be equal to what then if we're saying, if we're going to tip this triangular prism up like this so it's sitting on the triangle, what would be the actual height then? Yeah. Nope. 7 feet is, it's going to be 13 feet. Okay? So let's find the area of the base. The area of the base, if we're finding area of a triangle, does everybody see the base of the triangle? What's the base of the triangle? Nope. 7 feet. What's the height of the triangle?
7 times 6. 7 times 7 times.
Watch. Watch. In order to find height, we must have a right angle from the base. Okay? So it is 6. Whoa, I was going to write 2. Or maybe a backwards 6. I don't know. Now, if we do 7 times 6, are we going to find the area of a triangle?
You have to divide that by 2 though.
We do. We either have to take half of that or divide it by 2. We know that it's the exact same. If we did half of 6, what's half of 6, class? What's 3 times 7?
Oh, it's
21. What is 7 times 6? 42 divided by 2 is 21. All right, we'll do it one more way. What's half of 7?
3.5.
3.5, and now we're going to multiply that by 6. I'm going to use the distributive property. 6 times 3 is 18, and we're going to add that to half of 6. Half of 6 is, and that still equals 21. So no matter how we do it, our area of our base for this one is equal to 21 feet squared. Now we need to multiply that by the height. 21 feet times how many? What's the height?
21 times 13.
Yep, 21 feet times 13. I need calculators out.
Oh no, she got it. No, you don't.
I'm going to get, is it 273 feet cubed? Anybody know how I did 273 feet cubed in my head?
Oh, you did 6 times 1. Which is something.
I did 21. I actually did 21 times 10. What is 21 times 10? 210. Okay, that's this 10. 21 times 10 is 210. Then I found out what is 3 groups of 21. What's 3 groups of 21?
63.
63 plus 210? 273. So I can still use that distributive property. 273 feet cubed. Now, kids, this is an example of a problem. You will be able to use a calculator. Okay? The calculator on this one, the option to punch the button. Do you guys remember taking the OPA and the MCA? Where all of a sudden that the light, or not the light, it kind of it shows that you can actually click on the calculator. You click on the calculator and the calculator pops up. We would just have to punch in those numbers and make sure that we get the appropriate label. Does that make sense? I'm just going to go back and review. Our area of our base for this, if we're going to use area of the base times height, we have to do the area of a triangle. An area of a triangle is 1/2 of the base times height. And the base is determined by the height goes to the highest point, forming a right angle from the base. So I need to know what is the area of the base for this one. Everybody working on it right now. Find area of the base. All right, some of you may have used a calculator. What numbers did you punch in to find the area of the base? I'll tell you right now. I know the area of the base is equal to 72 meters squared. It's 72. And if you didn't get 72, it's you either didn't punch in the right numbers or you didn't use the right formula. So how did I get 72 meters squared? Go ahead.
Because you did 12, which is the base. I mean, 12, yeah, and then times 12, which is the height.
Well, it's going to make a fraction here.
You got 100.4, and then you did 100, and then half a pound for 4.
Now on this one, no matter how I do it, he just said half of 144 is 72. What's half of 12? 6 times 12 is?
72.
We're good to go. Now, how would we find the total volume then?
72 times 12.
Area of the base times the height. So we know that our volume is equal to 72 meters squared. And we're going to multiply that by the height. What's the height?
20, which is 1,440.
Which is 72 meters squared times 20 meters.
1,440.
Remember my cover-up rule?
That's what I was just doing.
Remember the cover-up rule? What's
44.
two groups of 72? 144. Add a 0.
1,440. Oh. I said 1,440. Yeah, I did. Yeah, I did. Yeah, I did.
I'll wait. The last one you're going to do on your own. Find the area of the base. Area of the base equals, and I need to find volume, what that equals. All right, what's the area of the base? No. To find the area of the base, we have to find the area of this triangle right here. So how do we find area of a triangle? Nope, just the triangle. I would agree with 3. We have to do half of 3 times what, class? 5. So 3 times 5 is, so we have to do half of 15. What is our height? Our height is what, Grace? It is 12. So now let's do 7.5 times 12.
See, Emma?
It should be 90.
Oh yeah. I knew it was good.
7 groups of 12 is 84. And then half of 12 is 6. 84 and 6 is 90. So our volume should be 90 centimeters cubed.